In this video, I will show you how to fill out a full truth table and how to use that truth table to determine if the argument is valid or invalid. So the first argument we're going to look at has as a premise the formula B arrow C. And then the conclusion is B or not C. And the question is this argument valid or invalid? So we start with filling in our guide columns. The two simple statements in this argument, there's just two, are B and C. So I've put them in the table in alphabetical order. The order actually doesn't matter. Actually, usually what I do is I put it in the order that the things occur in the argument, which just happens to be alphabetical in this case. So we start with the leftmost column, and we do true, false, all the way down. Then we go to the next guide column to the right, and instead of doing one true and one false, we double that. So we do two truths and then two falses. And since there are just two simple statements in this argument, we only need 4 rows, 2 to the second. So we're done with the guide columns. So then we start with filling in the truth values for the premise. And since this is an arrow, I know there's only one way in which it's false. And that's when the antecedent B is true and the consequent C is false. So I'm going to do that one first, and then the rest of them are all true. Then we need to fill in the truth table for the conclusion. Now I know that whenever B is true, the statement will be true. So I can do those first. So that's the first and the third row. Then I just need to figure out the others. So on the second row, B is false and C is true. So if C is true, that makes not C false. So that means we have false and false, so this statement will be false. On the fourth line, C is false, and that would make not C true, which would make the statement as a whole true. Then what I do is I look down the truth table for the conclusion, and I look and I see which lines where the conclusion is false, because those are the only ones I really care about when I'm looking for invalidity. I don't care about the ones where the conclusion is true, because I know that's not going to be a line that shows invalidity, because we need all the premises true and the conclusion false in order to show invalidity. So the only possible line to show invalidity is the second line, and that does in fact show invalidity, because the premise is true and the conclusion is false. So this argument is invalid. If the argument is invalid, we need to identify the counterexample, or a counterexample. There may be more than one. In this case, there's only one, because there's only one line where all the premises are true and the conclusion is false. And that's this second line here. So our counterexample will be B equals false, C equals true. So this assignment of truth values, when applied to the premise and the conclusion in the argument, will make the premise true and the conclusion false. So this is our counterexample. Okay, so now we'll do one more example. This one is a little bit more complicated. It has 2 premises and a conclusion, and it has 3 simple statements in the argument, G, H, and I. So we're going to need 8 rows in our truth table. So again, we start with the leftmost guide column, and we go true, false, all the way down. 8 rows. Then we move over one column to the right, and we do true, true, false, false, all the way down. Finally, in the third column, we need to double the number of trues and falses again. So we need to do 4 trues and then 4 falses. Okay. Then we go on to fill in the premises and the truth values for the premises and the conclusion. Well, I'm going to do the second premise, H, first because it's super easy. I just copy what's in the guide column for H. Okay. Then I need to figure out the truth value for the premise at each row. And it doesn't really look like there's any real easy way to do this. Because I need to have both sides true or both sides false on the biconditional in order for it to be true. So I have to just kind of figure out each one. So at the first line, G and H are true, are both true. So that makes the formula G and H true, and I is true. So the biconditional is true. At this line, G is false, so that makes the left side of the biconditional false. But then the right side, I is true, so this will be false. Likewise, the same thing with the next line, except that now it is H that is false, so this will be false. On this line, G and H are both false, so G and H is false, and I is still true, so this is false. Okay. On the fifth line, G and H are both true, so G and H is true, but now I is false, so this line is also false. Here we have, on the sixth line, we have G is false, so that makes G and H false. And now I is false, so this line is true. Same goes for the seventh line. Now H is false, so that makes G and H false. And I is still false, so this is true. And now we have everything is false. G and H are false. I is false, so that makes this line true. Okay. So now, let's see. Here we have G is true and I is true. That makes not I false. So not I is false, which will make G and not I false. But then we negate that, so it makes it true. So anytime that I is true, this formula is going to be true, as it turns out. So I can just do the next 4 are all going to be true. Okay, so now we have I is false, which makes not I true. So we have not I is true, and G is true. So that makes G and not I true, which makes the formula as a whole false. Anytime that G is false, G and not I is going to be false, which would make the formula true. So whenever G is false, the formula is going to be true. So that takes care of lines 6 and 8. So then we just have line 7. Here we have I is false, so not I is true, and so is G, which makes G and not I to be true, but then the negation makes it false. Okay, now to check for invalidity. We need to look at every line on the truth table where the conclusion is false. So there's just 2 rows. So there's this one and this one. So lines 5 and 7. We can see that we don't have all the premises true and the conclusion false on any of those rows. Because here we have on line 7, we have premise 1 is true, but premise 2 is false. And it's vice versa on line 5. Premise 1 is false. So we can stop looking. As soon as we find one false premise, we can stop looking at that line. So this argument is valid. Since it is valid, there is no counterexample. So we're done.